From the time our ancestors first looked at the night sky, we've asked one question: are we alone? That question has echoed through temples, observatories, laboratories, and the imaginations of storytellers. For millennia, it remained an open mystery. But in the 21st century, something changed. We built telescopes so powerful they could read the faintest light from worlds far beyond our solar system. And now, one of those instruments, the James Webb Space Telescope, may have delivered humanity's most profound clue yet. A distant planet, orbiting a red dwarf 124 light-years away, appears to contain a chemical that on Earth is almost exclusively produced by life. The signal is strong. The confidence level is 99.7%. It is not absolute proof, but it could be the closest we have ever come to finding alien life. The planet's name? K2-18b. Chapter 1. A planet unlike any other. K2-18b was first spotted in 2015 by the Kepler telescope. At first, it seemed like just another entry in the growing catalog of exoplanets. But astronomers quickly realized it was special. It is what scientists call a super-Earth, larger than our world but smaller than Neptune. It is about 2.6 times Earth's radius, orbiting within the habitable zone of its star, where liquid water could exist. Later, another label was applied: Hycean world. These are hypothetical planets with oceans covering their surfaces and atmospheres rich in hydrogen. Such planets may be far more common than Earth-like twins, making them prime candidates in the search for life. Already, K2-18b had the ingredients of mystery: water vapor, a hydrogen-rich atmosphere, and the right temperature range. But James Webb would add something far more startling. Chapter 2. How Webb peered into an alien sky. When K2-18b passes in front of its red dwarf star, a small fraction of starlight filters through its atmosphere before reaching our telescopes. James Webb, with its advanced infrared spectrograph, is capable of analyzing that light. Every molecule leaves a signature, like a fingerprint written in color. In 2025, Webb observed multiple transits of K2-18b. Scientists expected to confirm methane and carbon dioxide and perhaps find more water vapor. But then came something strange, a spectral signal corresponding to dimethyl sulfide, DMS. Chapter 3. The strange case of dimethyl sulfide. On Earth, DMS is not a common gas. You won't find it in volcanic emissions or drifting from rocks or produced by lightning. Instead, it comes almost entirely from living organisms, specifically marine phytoplankton. Tiny microbes in the ocean create DMS, which then escapes into the atmosphere, playing a role in cloud formation and even climate regulation. The idea that this same gas might be detected in large quantities in the atmosphere of K2-18b shook the scientific community. If the detection is correct, and if no abiotic pathways explain it, then K2-18b could be the first confirmed alien biosphere. Chapter 4. What does 99.7% mean? The team reported their detection with 3 sigma confidence, a 99.7% probability the signal is real, not random noise. In physics, 3 sigma is a strong indication, though not an absolute discovery. For comparison, the Higgs boson was announced at 5 sigma, a 1 in 3.5 million chance of error. So the DMS signal is not yet a smoking gun. But it is far beyond interesting anomaly. It is robust enough to demand the world's attention. Chapter 5. Could there be another explanation? Science is cautious, and rightly so. Skeptics argue that unusual atmospheric chemistry might mimic DMS. Volcanic activity, photochemistry, or exotic reactions under high pressure could conceivably produce similar molecules. Others caution that Webb's instruments, though extraordinary, still push the boundaries of detection. Calibration errors or statistical noise must be ruled out. To move forward, researchers need more Webb observations, cross-checks with other telescopes, and laboratory experiments simulating alien atmospheres. But here's the catch. Even if abiotic chemistry produces trace amounts of DMS, the quantities seen on K2-18b seem far too high. That tilts the scale back toward biology. Chapter 6. Imagining life on a Hycean world. Suppose K2-18b does host life. What might it look like? Underneath a hydrogen-rich sky with perhaps a global ocean stretching across its surface, life may have evolved in ways utterly alien to us. Imagine vast mats of microorganisms floating beneath the waves, feeding on chemical gradients, releasing gases into the atmosphere. Or towering balloon-like organisms drifting in the skies, adapted to lighter-than-air conditions. We don't know, but life, if it exists, would likely be microbial. And yet even microbes would shatter the illusion of cosmic solitude. Chapter 7. The wider impact on science and culture. The potential discovery of alien life, even microbial, would be one of the greatest shifts in human history. Philosophically, it would end the long-standing debate over whether Earth is unique. Religions and cultures might reinterpret humanity's place in creation. Practically, it would accelerate astrobiology, planetary science, and even technology development for interstellar exploration. It would suggest that the universe is not sterile but fertile. That life may arise wherever conditions allow. That we may someday encounter more advanced beings if time and distance permit. Chapter 8. A new chapter in exploration. James Webb was built not just to peer at the first galaxies, but to answer one of our deepest questions. With K2-18b, it may have done both, looking backward in time to the universe's birth and outward across space to glimpse another possible cradle of life. The work is far from over. More data will come. Skeptics will test. Models will be refined. But if this result holds, then history may record that in the 2020s, humanity first glimpsed its neighbors across the cosmic sea. We may not be alone, a planet bathed in the faint light of a red dwarf. An atmosphere laced with an unlikely molecule. A signal with 99.7% confidence. It is not yet proof. But it is a door. A door opening onto the greatest discovery of all, life beyond Earth. If K2-18b is alive, then so is the universe, and we are no longer the only story it tells.